In this lesson, we're going to cover Big Idea 6, Standard 2, which is on solubility curves. So here is an example of a solubility curve. So notice that we have temperature along the x-axis, and along the y, it tells us how many grams of solute can be dissolved. So we can see that we can dissolve a different amount of solute at different temperatures. So before we get to some example problems where we actually read this graph, there's two definitions that you need to be familiar with. So this unit we've been talking about solutions. Up first, we can have a solution that is unsaturated. If my solution is unsaturated, it means that the solute completely dissolves when the solute completely dissolves, it's going to leave no remaining solid. If our solution is unsaturated, we can dissolve more solute. Well, how do we know if a solution is unsaturated on our curve? We're going to notice that the point is going to be under the curve. So let's say we have a solution with 60 grams of potassium nitrate at 50 degrees Celsius. That point is under the curve. An unsaturated solution, you're going to find under the curve. We could also have a solution that is saturated. A solution that is saturated is at the point where no more solute can be dissolved. A solution that is saturated has dissolved the maximum amount of solute. What happens if we had a solution that was saturated and we tried to add more solute? Well, additional solute will appear as a solid, or we call that a precipitate. So if our solution is saturated and it can't dissolve any more solute, if you continue to add more solute, it's going to remain as a solid. Saturated is the point where it cannot dissolve any more solute. We are going to identify a saturated solution because it is going to be a point on the curve. So we'll do a few example problems and we'll see that. Alright, so we are going to use this example and do a few questions. Question number 1. How many grams of potassium chloride can be dissolved in 100 grams of water at 40 degrees Celsius? So the curve tells us the saturation point. That's going to tell us how many grams, the maximum number of grams that can be dissolved at a certain temperature. So what we want to do is first make sure we're looking at the right curve. So notice I have 3 different substances on my solubility graph. So I want to make sure that I'm looking at potassium chloride, which is this curve that I'm going to highlight in pink. We want to know how many grams can be dissolved at 40 degrees Celsius. So I'm going to look at 40 degrees Celsius, follow it over to the y-axis, and that will tell me how many grams can be dissolved in 100 grams of water. $40 grams. Question number 2. Will 80 grams of potassium nitrate dissolved in 100 grams of water at 50 degrees Celsius be a saturated solution or unsaturated? Alright, so now we're looking at potassium nitrate, which is my curve highlighted here in blue. We want to look for 80 grams of potassium nitrate at 50 degrees Celsius. So let's find 50 degrees Celsius. We're going to go up to 80 grams. Notice that it is on the curve. So this solution would be saturated. Again, the curve, this solubility curve, just tells me the maximum number of grams of solute that can be dissolved in 100 grams of water at a given temperature. So at 50 degrees Celsius, we can dissolve 80 grams of potassium nitrate. Let's try another one. Will 70 grams, let's stick with potassium nitrate, dissolved in 100 grams of water at 60 degrees Celsius be saturated or unsaturated? So again, first step is we need to find this point on the graph. So I'm looking for 70 grams, 60 degrees Celsius. 60 degrees Celsius, 70 grams. Next, make sure you're comparing it to the potassium nitrate curve. So I'm comparing it to this blue curve. My point is under the curve, so it's unsaturated. Let's do one more question for this curve. Let's say you were asked, how many grams of potassium chloride can be dissolved in 200 grams of water at 70 degrees Celsius. So this one is kind of a tricky question. So I want to look at potassium chloride, KCl, which is my curve here in pink. And I want to look at 70 degrees Celsius. So let's find 70 degrees Celsius. How many grams can be dissolved? 50. However, 50 grams is not the correct answer. Notice the y-axis. This curve is telling me how many grams of potassium chloride can be dissolved in 100 grams of water. Notice that this question is asking us how many grams can be dissolved in 200 grams of water. So, if I have twice as much water, that means I can dissolve twice as much solute. So I'm going to take my grams of solute, multiply it by 2. I would be able to dissolve 100 grams of potassium chloride in 200 grams of water. So for these questions, be mindful of how many grams of water is our solvent, and pay attention to that y-axis. All right, there's a few other types of questions that you might be asked, and let's look at a new curve for those next round of questions. Question number 1. What temperature is required for 80 grams of sodium nitrate to be dissolved in 100 grams of water? So I have 80 grams of sodium nitrate. I'm going to dissolve it in 100 grams of water. At what temperature does that solution need to be at in order for it to dissolve? All right, so we are going to find 80 grams of sodium nitrate, which is right here. 80 grams sodium nitrate. What temperature does that solution need to be at? 10 degrees Celsius. Question number 2. Let's stick with 10 degrees Celsius. Which compound is most soluble at 10 degrees Celsius? So for this question, we are only looking at 10 degrees Celsius. And we want to see which compound is most soluble. Whichever one is most soluble can dissolve the most solute. So at 10 degrees Celsius, which curve can dissolve the most solute? Sodium nitrate. Sodium nitrate can dissolve 80 grams. Calcium chloride, only about 63. Lead 2 nitrate, about 55, 56. Whichever compound can dissolve the most solute will be the most soluble. Let's go the opposite way. Which compound is least soluble at 10 degrees Celsius? So again, we're going to look at that blue dotted line that I drew in. Which curve at 10 degrees is going to have the least amount of solute dissolved? KClO3. All right, 2 more questions. Question number 4. If 50 grams of sodium nitrate were dissolved in 100 grams of water at 10 degrees Celsius, how many more grams of sodium nitrate can be added before the solution is saturated? "50 grams of sodium nitrate at 10 degrees Celsius, which is right here. We want to know how many more grams can we add until the solution is saturated. Well, this solution is saturated at 80 grams. So if this solution is saturated when we add 80 grams, but we have only added 50 grams, how many more grams can be added? 30 grams. So again, looking at our curve, at 10 degrees, we only added 50 grams of sodium nitrate. I can add 10, 20, 30 more grams until that solution becomes saturated. Last question. "30 grams of potassium chloride is dissolved in 100 grams of water at 10 degrees Celsius. The solution is heated to 40 degrees Celsius. How many more grams of potassium chloride must be added to make the solution saturated?" All right, so let's unwrap this problem. 30 grams of potassium chloride at 10 degrees Celsius. So potassium chloride is this dark blue line here, and I want to look at 10 degrees Celsius, which is right here. So we initially dissolve 30 grams at 10 degrees Celsius, and notice that that solution is saturated. We are now going to heat that solution up to 40 degrees Celsius. If we want this solution to be saturated at 40 degrees Celsius, how many more grams do we have to add? Well, in order for the solution to be saturated at 40 degrees Celsius, I would need a total of 40 grams. We initially added our 30 grams when the solution was 10 degrees Celsius. So how many more grams do we need to add in order for the solution to be saturated? We would have to add 10 additional grams.